Well, I managed to squeeze this setting. I'm very busy as a church organist, as you can imagine, in December. Kernow Beta 2100 in the same box as another Harrier CBX. So, seeing as we've just done a Harrier CBX, I thought we would move on to this set instead. So, Kernow Beta 2100, supposed to be a general service, faulty channel selector, that's interesting. Hope it isn't, I don't know what I'll be able to do about that. PACB switch intermittent, that probably wants cleaning or taking apart by Mr. Chippy. Internal speaker no sound. I seem to have got my video screens not normal. Let's see what's happened. Oh well, it looks normal now. I'll be doing this in 20-minute bursts. It's quite cold in here. I would estimate it's about 12 degrees centigrade. There is heating, but clearly the electrical heating is inadequate when it's so cold outside. And I certainly can't be affording to put bucket loads more on. Now it's come with an instruction book, so I'll just make sure that I've got this scanned. So we'll do a quick evaluation. I was told by the wholesaler at the time that these came out of the same factory as the Midlands did at the time. Now that's presented with a cigarette lighter plug, which doesn't help us, but see if we can get the crocodile clips to stay on for the duration of the video. So I won't plug in the extension speaker. Plug in the test equipment into the antenna socket. Clearly the set's kind of working, so switch the power supply on and at 13.8 volts, and it's one of those sets that looks like it boots up on channel 9, which is very frustrating. Let's have a look at this PA situation. And hopefully there's the mic. So these sets were mid-90s. As such, it's showing PR2794, which sometimes confuses people. This is the upgraded version of 2781. So still the UK set of 40 channels, but it isn't like PR27GB, which is a CPT set of 40 channels, which, as I keep saying, don't work here, unless you want half a mile range. Right, switch to PA. Testing 1 2, testing 1 2, 1 2 1 2, testing 1 2 1 2. Sounds like a noisy PTT switch. Might just need. That switch is a bit floppy. Mind you, says the other one. Might gain high or low. Is that right? Let's go back to PA. 1 2 1 2. 1 2 1 2 1 2 1 2 1 2 1 2 1 2. It does the opposite, doesn't it? Why does it do the opposite? That's bizarre. Right, let's put the picture-in-picture on. Oh, we're not on the right camera. So just see how this affects deviation. I'll put my monitor receiver on. We'll turn the thing from... It's just a rotary encoder, this channel switch. It's not real, so I can't worry about the channel switch because it's not It's just, yeah, it's loose and horrible, isn't it? Yeah, that's what it is. Testing 1 2, testing 1 2, 1 2 1 2. So we'll switch the mic gain while talking into it. 1 2 1 2 1 2 1 2. Wallow 1 2 1 2 1 2. Not seeing anything happen there. 1 2 wallow. 1 2 wallow wallow. I can't see any change unless it's a different function and it's high-low power, which it doesn't need to be because it's not 27. No, it seems to work on PA backwards, but it doesn't seem to do anything on CB. I might have to open a set of ours up and see whether this has been fiddled with. So we'll go to power. Well, deviation there. I may as well write these things down. It's an outside carol service outside the pub at Ancaster this evening at 6, so I'll have to take my horrible electronic keyboard along and play that and catch my death of cold outside the pub. Likely to be -2. Where's the company pen gone? Oh well, we won't write down the parameters yet, but we won't alter anything. Wallow, wallow, deviation doesn't look right. 1 2 1 2. Let's put that in that high position. It is in the high position. 1 2 1 2 1 2. Wallow, wallow. It's about 1.5 the deviation, which is rubbish. So we've got just under 3 watts on transmit power, and we'll put the receive into the signal, or see whether it's on frequency. Let's just show you that. I must say the signal generator has only been on for 10 minutes. Yes, it's significantly off frequency, even taking into consideration the test set needs to be warmed up a bit. So we will set the signal generator also off frequency, so 2779062, wasn't it? So we'll just check that again. So transmit 2779062 and the receive 27790. Well, it was 62. Right, so that's now fair. So we'll put the synod meter on. We'll put some volume on, make sure the RF gain's up. So we've got nothing coming through the internal speaker, just how he says. Imagine I've got nothing coming through the external speaker either. What am I doing wrong? It's the PA speak. As he says, it's the PA switch which is causing that problem. So there we go. We've got those controls in the right position. That's an S9 signal. Let's turn it down and let's look at the synod meter. Actually, it's very good. It's 0.52, which we can't write down, but I'll do that later. So I think I'll go and look. I'll take the lid off. We'll take the lid off. We won't touch anything. And I'll put the soldering iron on because I think they have to be unsoldered on this model. I think my Kernow, my favourite Kernow is probably the Beta 1000, which is the one with no meter. I like sets with no meter. It may be recoverable. The lid's been opened up and the speaker's been broken as a wire has snapped off. I can see that. And it might be possible to reconnect that. So somebody's just opened it up, whip, and they've snapped the wire just there. Simple as that. So I'm sure that will be all that needs doing. So what we'll do, we'll just put a bit of a few strands of wire on that. I'm not going to try and solder that to there because it has snapped. And so we'll extend that wire a little tiny bit, and hopefully that will be cheaper than trying to find a speaker that fits for a £5. We'll put that on one side for later. I think we're going to have to take the other lid off because we're going to have to look into this switching snag. We're probably going to have to take the front off to see why the channel selector switch, or the rotary shaft encoder, if that's what it is, see why that's playing up. Because it is loose. Oh, so I'm doing this on Friday, what is it, 16th. Got a wedding tomorrow amongst the carol services. That's going to be interesting to cram in. You know, that's loose, isn't it? But why is it loose, you know? Yeah, it's loose because the encoder looks like it's simply got a loose nut. So if we pull the knob off and deal with its nut, so the nut is off. That's what's wrong. So what we're going to do, we can use virtually any tool to start it off. I don't have a pin driver. I once ordered and paid for a pin driver from America, but it never arrived. So that has tightened it up as far as finger tight, and we'll go in with these good. Well, that's the end of that problem. So it's a matter of trying to get some switch cleaner in these. Because they're both about as flimsy as each other, I don't actually think they're faulty. They're probably just dirty. So there's a cover. So lifting the cover, we should be able to get the service on nozzle to get some switch cleaner into that. Because that one seems to be working all right. It's a CBPA one. But the trouble is, if you wanted to dismantle those, you're not going to get them. You're not going to replace them. So to get to them, you've got to unsolder the connections to the mic socket, take the knobs off, unscrew the fascia, and take all that off. So you've got to think that's going to take 40 minutes plus. That's all right if you're a hobbyist and you've got all the time in the world. But as a commercial two-way radio engineer, you've got to kind of do a balance between what the set's worth and what it's going to cost to make a change like that. and I don't think we're going to get a better benefit. To be honest, both switches are flimsy. That's the best way to describe them. We have to appreciate this is a cheap set. So at that point, I'm going to see whether we've got this on file, and we'll come up with the circuit diagram which will help us find out which thing does what. So at least we've got a start. We've got that rotary channel selector thing tight again. Right, so I've re-scanned this instruction book because I've got some better software than I had when I did it before in the 80s. We just had a photocopy, didn't we? So I've been able to clean this up, and that will include the circuit diagram. So I've looked at that on the computer. This doesn't look like the normal camera angle. Well, perhaps this is bigger. So I've been through and gone through some of these things on the circuit as to what's going to need adjusting. I didn't bring the service hole, did I? So we'll worry about the PA switch later. So, channel 20, turn the volume down, and so I've got that I'm expecting the transmit adjustments to be T8, 9, 10, 11 and L3. So, and 8's going to be the VCO possibly for that. So 8, we'll see, 8, 9, 10, 11 and 3. Now I think it's got a power control which is VR3, which is that one. So first of all, are we on picture in picture? No, we're not, and we're not on the right camera, so we'll just get that sorted. Press channel. It's one of those, is it? We have to unplug the extension speaker. So let's see whether that does adjust the power. It does, yeah. So we need to crank it to full to do these adjustments. Oh, it's 4.2. So we'll be as quick as possible because we don't want to overheat the PA. That was a slight improvement. So it is 8. 5.4 and a bit. Sorry, 4.4 and a bit. 4.4. Of course, if you go into transmit for too long, the power's going to start dropping off rapidly. 4.5, and finally 4.7. Now we drop the power to 4. Now we have it. Good. So I've come to the conclusion that VR6 is deviation. No idea what the other ones are. Well, let's put it on frequency while we're at it. So everything's been warmed up. It's about 90 minutes later. Apart from me, of course. 2779, it should be 125. I hope that doesn't mean the crystal's duff. It does. Yeah, I can't pull it up. So the reference crystal is now out of spec. So we'll have to see what we've got. I think we'll do other things because I can still carry on with everything else. So I can't see where this is adjustable for the meter. I really can't. Let's look at deviation. can find it. See that one at the back? Yeah, it is. Wallow. 1, 2. 1, 2. Wallow. 1, 2. Wallow. 1, 2. Just over the top now. It was at minimum. Wallow. Still over the top. Wallow. That's it. So we're trying to get it to be the kind of 2.2 average, an absolute peak of 2.5. So that's that sorted. So that leaves us with, we know VR1 is squelch, which is there, but we don't know what VR2 is. I couldn't find that one on the circuit. I probably could have looked harder. It could be that the S meter is adjustable, but the RF meter isn't. So let's go over to receive. So let's look at what frequency we're on and we'll set the receive up accordingly. So we've got 2779079. So go over to receive and we'll put in 2779079. 079. So if we set this equally off frequency, then when I change that crystal, if we can do that, everything will come in spot on. So it was already very good at 0. Oh, I've had to unplug the speaker, haven't I? 0.52, wasn't it? There we go. So as ever, we will start off by putting an S9 equivalent signal on of 100 microvolts, just making sure the RF gain's fully up, and we'll look at that on the oscilloscope. And what I'll just do is see whether we've got the maximum recovered audio. T5's the discriminator. Yeah, it wanted adjusting. That's now adjusted. We'll now drop that and we'll look at the synod meter. We'll drop that till we've got about 4 dB there. And we'll go through T1, 2, 3 and 4. So I've got 1, 2, 3 and 4. Not far out at all. That next one looks to be an IF one. We'll just check that. Let's see what we've got now. Exactly the same, 0.52. So no change there. So our mystery was, does this, let's put S9 again on the signal generator, 100 microvolts, just see if this mystery preset is the S meter. Yes, it is. So we set that, so it's just S4, just about 4 bars for S9. That's probably about where it needs to be. So you see, that was a mystery. It wasn't. I can't find that on the circuit. So we'll now do the squelch. So we're going to turn the squelch to full on the radio. Now I'm going to turn the signal generator so that we've got 100 microvolts, 10, 30, 100. It comes in just where I want it. It doesn't need adjusting. But if I did need to adjust it, we would want to very carefully adjust VR1 until the squelch just opened at 100 microvolts. So we'll do the opposite now. I'm going to put the signal generator to 0.3 of a microvolt and switch it to standby. Now we'll turn the squelch all the way down and set threshold. Switch the signal generator back on. See where it comes in. Comes in at 0.32 of a microvolt, and it leaves us as 0.29 of a microvolt. So, sorry, 0.22 of a microvolt. So 0.32 to come in, 0.22 to go back out. So it's got good hysteresis. So that should track Mr. Chippy very well around Scratchy Corner. So the set's done. I just need to get the switch cleaner on that switch and we'll see if we can change that to that crystal. I'm going to switch the set off, switch the soldering iron on and see what we've got in crystals. Right, so I found a second-hand crystal. The one that's fitted is the smaller type, and we've got these in stock, but all ours are reading slightly too high to trim down. So I found one on a scrap chassis, which is a conventional size HC18 type, and it looks like we're going to be okay. So let's put the frequency counter on. This will need trimming again when it's cooled down from soldering properly, and I've put the bottom on. So yeah, this is going to be great. So that's the radio back on frequency. Good. Well, that can go in the vertical filing cabinet if there was one in here. So I just need to do the service hole on that, but I'm going to have to take a break because there's things to do. Right, so we're going to fast forward now. It's now Sunday. I'm between church services and I've got 15 minutes. So we'll try and get this finished and then we can do an on-the-air test this evening with Mr. Chippy. So where we'd got with this is it was done. We just needed to see if we could just simply clean those dodgy switches. So it's a matter of getting the shroud out of the way. The difficulty here is we've got a microphone connector that's soldered and connected from the outside, kind of thing. We'll just pop these screws out, just see if we've got enough leeway . What I don't want to do is to break the set, and the other thing I don't want to do is to spend a couple of hours unsoldering the front panel and unsoldering the switches to swap them over for a lesser used one. Of course, I don't even know if the customer needs PA to work, but there you go. I've been asked to look at the switch. Yeah, you know, straight away you've got the next snag. That the all the knobs, all the potentiometers are screwed through, so you've got to undo all those to get into there properly. It's just a nightmare. I can't get the long nose pliers down there. See how tight these are. They're just such a flimsy design, these switches. I'm going to take it a stage further and I'll see if we can get the surgical scissors in and actually remove. So that's another trip to Mr. Chippy's bench. Guess we can get that precision screwdriver in there. I can't shift that one. No, I'll pause the video and get some surgical scissors. What I've been able to do is I've been able to shift two of them with one of Mr. Chippy's dental tools. Let's see if we can finally move this third one. Have another idea. Get that in there, get the precision screwdriver in there, and see if I can shift it with two tools. Right, it's gone. There's some crud in there which has probably been jamming it. And of course I've got to put these back and sufficiently tight. So I think between the lubricant and the dental tool and the precision tool we've finally got there. These ones are normal. Shouldn't have to take the channel one off because we're just going to slip it away. So now I can remove the shrouds. We'll put some switch cleaner where we can actually see. Make sure they're tight. Right, I'm going to power it back up. So we're back on. We're in PA position. I'll just try and move that lever with screwdriver. And it has gone into CB. So we'll just try and put this back on along with the shroud that's come off. I don't even know how that came off because it's so tight. Right, we'll unpower it again. So we've got to get those switches through the fascia holes and all these controls kind of at the same time. Okay, so it's now Monday evening, and I've had Mr. Chippy just solder something on here, and we should all be good to go. I'll just check it on the test set. It actually still transmits. Oh, I need to put these knobs back on. Now what I've found is that the actual controls are a bit, well, they're cheap and nasty, aren't they? Let's be frank. But they are, although the nuts are in tightly, the actual controls are a bit floppy. So what I have done is to put some hot glue on the back. I'm just going to hold these while I put these knobs on. So it doesn't all collapse. So they're now not as floppy as they were, which is exactly what we were aiming at. So you can see I've just used some hot glue just between the plastic front and the metal body of the control, but they're very flimsy, these. So we'll just power it up, check it still works. Helps with the negatives on the cigarette lighter plug. Right, let's try again. This draws 17 milliamps when it's not on, so just as its memory backup. Just bear that in mind if you've got it in a car and it's powered all the time. So I'll just key it up. Yep. Wallow. Let's have a listen. Testing 1 2 3 4 5 5 4 3 2 1. Well, it's not jumping around on the monitor receiver. Let's just look again at the instrument. Wallow. 1 2. Wallow. 1 2 1 2. 1 2. Wallow. That's fine. So I'll just check it's on frequency. It shouldn't have changed. Yeah, that's fine. And we know it's receiving. Just plug the extension speaker in. That's interesting. Oh, the plug's coming out. Fair enough. I didn't use the locking thing, did I? Yep, that's still receiving great. Okay, so we'll put the lids on it. And I'll try and do something with that. I'll put the soldering iron on. I'll try and do something with that broken speaker. Oh, there's a bit of glue there from manufacturers to get that out. Now, why didn't I tighten those up? I did the other side, I must have been losing the plot. So I've got to try and deal with this broken bit of speaker wire. So I'll just get a bit of flexible wire kicking around on the bench. There's a bit of braid here which is off a microphone job, and it's just a matter of carefully soldering it to the, as you can see, it's being snapped away as somebody's undone the set without looking at how much wire there is. And newer sets are real good at not having much wire on them. Be very careful. That's a very delicate bit of wire. I'm going to wrap it around that terminal, so we've got a mechanical joint. Like that. And then let's hope, if we get the meter out, that we've got it reading some gnomes. We have. So you can see what I've done with some multi-strand wire there. You know, it is tight, the wiring, and you've just got to be aware that they can be. Right, I'll switch it on. Unplug the extension speaker. And there we are, internal speaker working. Back into transmit. Excellent. Turn the test set off. Unplug the aerial. All ready to plug in the roof aerial. I'll put some of the screws back. Thank goodness it's warmer today. We've been having it was as low as -6 overnight over the last week, and today it's +13 at its peak, so can cope a bit better, and the temperature in here will be probably 18 as set. There's just a 500 watt electric convector heater on in here, which is usually more than adequate on its thermostat, and as you know, we spend a lot of time with having to have air conditioning on. But certainly not this December. Now the next set I'm going to slot in is nothing to do with any repairs. I'm going to slot it in my own time, and that's a Maxcom 4E, And part of that is we've got a Maxcom mic to repair from this customer. Now I bought this Maxcom for, I think it was 18 quid delivered off eBay as I buy it now. So I thought, well, I may as well do my own Maxcom 4E, and that will pave the way to sorting out the customer's mic. Now I've ordered an insert from China because they seem to work better than the expensive ones from Farnell. So now when I tipped the pot of screws over, it looked like one didn't want to stay. Is that it? Yeah, that's the last one. I've tried glass pots, I've tried plastic pots, I managed to tip them all over. Right, there we go. So, switch it on. So once again, I'm going to demonstrate this mic gain thing. It doesn't seem to do anything when it's in CB mode. Let me show you. We're on an aerial now, so I don't want to be messing about too much, but right. So listen to the volume. Testing 1 2 3 4 5 5 4 3 2 1. And now we're going to high gain 1 2 3 4 5 5 4 3 2 1. And whilst transmitting, going back into the lower gain, I can't actually tell the difference. Now if we go into PA, oops, wrong speaker, on the proper speaker, that's that one. So that's mounted on the wall. So go into PA, and with these you've really got to not try and push them from the top, but you've really got to get them from the bottom, so you've got the whole shaft. Testing 1 2 3, testing 1 2 3 4 5 5 4 3 2 1. So without changing the volume, you can hear me, and it says in its high gain. I'm going to carry on talking, and it's actually louder now. It's in mic gain. So it's the opposite way to what you think. So I think if we leave it in that position, that will be correct. And it unfortunately makes CB come over the PA speaker. So we'll now go back to PA, to CB, and it has actually gone back to CB. If you're wanting a set to be going from PA to CB and CB to PA, this isn't the set for you because these switches are too flimsy. But at least it works. Right, so we'll put the hand portable away. And that switch isn't wired back to front, it's mounted on a printed circuit. It's the way it's made, so it's a cocker. So just make sure we've got something near. 1 nano, Roger. $19, Roger. And there we are, nobody on. Good. I'll do an on-the-air test with Mr. Chippy. And there we go. So, long and drawn out, you have the Kernow Beta 2100 from around 1995. Thanks for watching.